Hello and welcome to another tutorial. We are looking at the object-oriented programming concepts, and we saw that when we discussed objects, we said that bundling code into individual software objects, basically instances of a class, provides a number of benefits. And the modularity, you can break your code down into smaller pieces, and each piece is for a particular class or object, and then you put them together and solve a bigger problem. The source code for an object can be written and maintained independently of the source code for other objects, and this is the key. And this is also one of the concepts which is called separation of concerns. Each object has to be concerned with a small group of data and a small group of actions or behaviors, that basic actions that happen on those data. And then the idea is that you have to have something called loose coupling between your objects, which means objects should not really depend on each other. Obviously, sometimes this is unavoidable, but then it's best to be able to independently develop the code for each object or each class, basically, that describes that object, and then test them. Once you are confident that the code is right, now you put them together and solve a bigger problem. So once created, an object can be easily passed around inside the system. And again, if you are not familiar with the concept of references or pointers, in C++ and Java, everything you can pass around everything as pointers or references, right? Java really hides the concept of pointer. So to the software developer, to the person who writes the code, when you write car, other model, for example, this is a reference to other object. In C, so basically in C, you kind of need to do something like, or C or C++, you kind of keep this as a pointer, car pointer, right? Other model. And but Java hides this fact, and under the hood, JVM realizes that what you actually mean is a reference to the objects, right? So this instance is created on Java heap, and then the actual object. But then this variable, remember, this variable is this name other model is a variable, and any variable has to have a type, and this variable has a type of car. What this actually means is that this variable holds the address, memory address of that object, of the actual object in Java heap. That's why you can assign another variable to basically this variable, and both these are just pointers that point to the same objects in the memory, right? So you have to be careful when you pass objects around, variables that pointing to the object. So in Java terminology, we call them references, right? So in C, C++, these are obviously pointers. I will show you an example later that in C++ they also introduce the concept of reference. So you can have car reference, right? This is actually, to be more exact, this is L value reference, and then you can have car ampersand ampersand. This is R value reference, right? Usually when we say references in C++, we mean car ampersand, for example. And again, what this means is has a similar meaning as the car here in Java, right? This variable, it just means if you have multiple references to the same object, they are exactly pointing to the same object, right? Same here. If you have multiple variables that pointing to the same object, it just means they all are equivalent, right? All right, information hiding or data encapsulation. We discussed this by interacting only with an object's methods. The details of its internal implementations remain hidden from the outside world. Code reusability. And again, this comes either in the form of inheritance. You already have a class object that you fully tested, and now you inherit from it. You get its all behavior and functionality, but then you override part of the methods, which means you are changing only part, a small part of the behavior. Now, obviously, if you have override many methods, this means maybe inheritance is not the best solution for your problem, right? Usually you go the inheritance route if you only think that you have to override a small part of the behavior of your original object, like one method or two methods, right? And that makes sense to go down the inheritance route. If you think that you have to change a lot of things or introduce new behaviors, then it's better to go with composition. If an object already exists, perhaps written by another software developer, and also sometimes you don't have access to the source code. You only have, let's say in Java you get a jar file, it only has the binaries, so you cannot go inside the that code that maybe it's written by some other software developer, right? You don't have access to the source code. You only have access to binary. Now these days you can obviously have class decompilers that decompile your class and give you a relatively good representation of the source code that made that class file or binary file. But again, most of the time you don't even have access to basically the source code. So but if the library or the other software other code that you have the binary only, it allows you to inherit from the classes defined there, then you can go the inheritance route and change a small part of the behavior of those objects so that you can solve the problem that you are facing. You can use that object in your program. This allows specialists to implement, test, debug complex task-specific objects, which you can then trust to run in your own code. Pluggability and debugging ease. Again, if a particular object turns out to be problematic, you can simply remove it from your application. So when you have a small objects, small classes, then first of all, you can test them separately, make sure that they work fine, they don't have any errors. And sometimes you fake, if your class or object requires some data to perform some actions, and you can provide some fake data, for example, and then test your class to make sure that it works fine. If a particular object turns out to be problematic, you can simply remove it from your application and plug in a different object as its replacement. So this is sometimes called mocking or a mock test. We have a Java framework that actually does this, right? So you fake your object with another like handmade code or fake code and then see how it behaves. This is analogous to fixing mechanical problems in the real world. If a bolt breaks, you replace it, not the entire machine. Again, that goes into the fact that you write your code in a modular way. You use a smaller objects and put them together to solve a bigger problem. So what is a class? So far we talked about objects, and then what is a class? And again, the classic definition or a textbook definition of a class is a class is a footprint for an object, which means class defines a particular type. Remember, we're using a statically typed language like Java or C++, right? And so a class, first of all, it defines a type, or sometimes called a user-defined type, UDT, for example. And then it groups some data and some actions or behavior. This is the footprint. And then you can use this footprint or definition to create multiple objects, and each object of that type, of that class, can hold its own data, its own variables have different values, right? But then all of them exhibit the same behavior on the data that is associated with each of its object, right? So when you define the footprint, you define some data which are in the form of variables, right, fields, and then actions, and different instances of this class or different objects of the class. When you create new objects of that type, of that class, they get their own data, so their states can be different, but their actions on each object has its own data, but all of them kind of have the same behavior on every object's data, right? So the behavior is the same, but the data is different. That's the meaning of kind of object-oriented programming. In your applications, you will often find many individual objects. Again, object means an instance of a class. You have created an object of a class. Remember, class is more like an abstract footprint. And then objects are concrete cases, right? Objects actually hold memory, and because they have to have values for their data, right? And they hold the state. Individual objects, all of the same kind. All of the same kind means they all are created from the same type, right? The same class footprint. There may be thousands of other bicycles in existence, all of the same make and model. Each bicycle was built from the same set of blueprints and therefore contains the same components. In object-oriented terms, we say that your bicycle is an instance of the class of objects known as bicycles. Again, a class create a user-defined type, so it's a type. So when you assign a variable to that particular type, it means it's pointing to an object that has this particular footprint. which determines what kind of data this object holds, how much memory it needs, right? The compiler or at runtime, the JVM looks at the fields of this class and realizes, okay, int is 8 byte and we have 3 variables, so this class at least has or requires like 3 8 bytes or 24 bytes. Now in Java, it's a little bit more complicated. I'll show you that in C++, when you define a class, the exact size is pretty much the size of the variables if you add them up. Sometimes there are special cases when the values don't line up with the powers of 2. Remember, computers, when the CPU wants to access memory, it's always, basically we have something called a bus lane, a bus memory address. Bus lane between CPU and memory, usually it's always a power of 2, like 2 lanes, 4, 8, 16, 32. At the moment, I think we have more than that. I think currently for the 64-bit CPUs, the memory address lane is 64-bit, right? And usually the computers don't take advantage of all of this. We usually maybe even less than half, like 32-bit addressing. That's just because so a 32-bit addressing for a memory, if you already know or aware that it requires a maximum of 4 gigabyte of RAM. But for a 64-bit addressing, which 64 CPU means it can put a 64-bit address to read the values from memory. And then the address space is much larger. It goes into the terabytes, right? Hundreds of terabytes of RAM, which we probably never have. Like a single computer usually doesn't have that much RAM, right? So 64-bit addressing is not necessary. But the thing here is that there are variables, for example, a char type that are only 1 byte. And the problem is that when you want to access 1 byte, you usually, or in reality, you never read only 1 byte. You usually read, for example, 8 bytes, right? Or something like that. Sometimes if you are, again, in C++ mainly, that could be a concern that when you define a class and the size of all the variables doesn't add up to like 8, 16, something like that, then the compiler adds some extra zeros, which is called padding, so that you do an alignment, so that the size becomes a factor of 8, like 8, 16, 32, 64 bit, this kind of stuff. So you lose some extra memory, but then reading becomes more efficient, right? Again, this is a concern that you don't have or you don't deal with in Java, assuming that the JVM has been fairly optimized to deal with this kind of stuff, right? Again, one of the attractions of Java is that a lot of these low-level details are hidden and the developer doesn't have to be concerned with that. All right, so a class is the blueprint from which individual objects are created. And in simple terms, it just means the class defines if I create an object of this type, bicycle, how much memory we need and or what kind of data it's going to hold, and based on that the JVM determines how much memory it needs, right? The following bicycle class is one possible implementation of a bicycle. So it has some behavior, it has some data which defines the state of each object when I create them. Now another thing is that as I mentioned before, in Java, each class gets compiled to a separate class file. So if I go back to my navigator and look at my source code and look at OOP, as you can see, I have a car.class, right? Every class is compiled to a separate class file. Even if you have multiple class definitions in a source file, in a .java file, each one gets compiled to a separate class file. And I've mentioned this before, that's because JVM is lazy, or basically it operates based on the concept of lazy loading, which means if you have this class in your source code and in your actual application you never create any objects of this class, then JVM says, okay, there is no point for me to load this blueprint, this car.class, right? This is the blueprint into memory, because each class has to be loaded in the memory so that JVM knows how to construct objects of that type. And it just simply means what are the variables that are this class holds, this blueprint holds, and therefore JVM knows how much memory it has to allocate when you create an object of that class. But just holding the data of this class, like what kind of method it has, what kind of variables it has, it takes extra memory. And later we will see that This is saved in some part of Java heap called the meta space, which, as the name implies, it means that JVM keeps track of the meta information that is associated with each class file that it loads, right? And that directly ties to the Java Reflection API, which means at runtime you can reflect on the objects and then change the behavior even after you construct a particular object. And obviously this is something that we definitely look at in the future lectures, right? So the syntax of the Java programming language may look new to you, but the design of this class is based on the previous discussion of bicycle objects. The fields cadence, speed, gear represent the object's state, right? As we said, non-static fields define the values that each particular object or each particular instance of a class can hold, which means it defines the unique state of each object. And the methods define its interaction with the outside world, right? If I give somebody an object of this type, they can call this method, assuming that all these have access modifier like public. So the user or the end user is allowed to actually access these methods, behaviors, and actions. And know that all these methods, the reason we call them action, because they actually act on the state of the object, given that the methods are not static, right? Because non-static methods only can access the non-static fields of a class. For example, when we say apply break and decrement, speed is part of the state, right? It's a field of the class which is part of the state of the object. And then when we apply this method or action, it actually changes the state of the object. And as I mentioned before, this means we are mutating the state of the object. You may have noticed that the bicycle class does not contain a main method. And again, main is a static method, which is the entry point to your application. Now, as I mentioned, in Java, everything has to be inside a class scope, right? You cannot have a separate main that is not part of any class scope. There is no global scope in Java, right? We've seen that in C, C++, there's always a main function. And again, that's the entry point to your application. But that's not part of any class, right? Main in C++ is always in the global scope, which doesn't belong to any class. But then in Java, we don't have a global scope. And then the question is, how do we define a main, right? Where should we put it? And the answer is that you can have main in any given class. So multiple classes in your Java file can have main methods. And then the way you run your application, you point the JVM to which main method, which class, which main method of which class you want to call, right? So it's a very interesting thing that, for example, in all of my previous examples, we've seen that different classes had different methods and different main methods, right? So there is no, that's one of the nice thing about Java, there is no restriction to only have one main. And that's the restriction that you actually have in C++, right? Because main in C++ has to be in the global scope, and in the global scope of C++, there is only one global scope, so there can only be one main method. But in Java, each class has its own scope, and you can therefore you can have a main method in each class. And then when you run your application, you tell the JVM which main method to run, right? And that's a very nice thing to have. It's very easy, makes the like running application much easier. And basically, when I right click on a class, right, and then say run as Java application, what happens? Actually, Eclipse does a very nice thing. It creates a run configuration and it tells me what is the main class. So when I'm, for example, when I'm in this for loop and run it, it runs something, right? And then if I look at the last run, it tells me that the last application that I ran was from for loop, which means I ran the main method inside this class. If I look at the run configuration, as you can see, Eclipse adds a lot of stuff for this particular. So it tells me which class had the main method, right? Main. And the project was dev.java, and the class was in this package, and this for loop, which means I actually ran the main method inside this class for loop, right? And that's why it's called main class. Main class means the class that actually we ran the main method for it, right? And then arguments, you can have arguments for your program or your JVM, and then there are some default flags that the Eclipse automatically runs the JVM with. You can define which JRE to run. I'm using my workspace JRE, which is JDK 16. You can have dependencies. Obviously, I'm not using any modules, but my module has the original or the normal JDK dependencies and my source file in the application. In Eclipse, you can have a dependency on other open projects, etc. And then it tells me what are the source files, and I have my project, and then basically the JRT, right, Java runtime. And then environment, you can define environment variables if your application requires some specific environment variables. There are some common things that we don't really talk about. And prototype, these are also something that more about advanced topics. But the main thing that I wanted to show you here was about basically the main, which means when we run something, some stuff happens behind the scenes by your IDE, and again, it hides the complexity and makes life much easier, right? And so that is because it is not a complete application, which means if this class doesn't have a main method, it's not we're not going to run the application. Some other class must have a main method, and the only thing that we can do with this class to create objects of this type. It is just a blueprint for bicycles that might be used in an application. The responsibility of creating and using new bicycle objects belongs to some other class in your application. Here is a bicycle demo class that creates two separate bicycle objects and invoke their methods. So again, the drawback of not having a global scope is that if you just want to define the entry point to your application, which means a main method, you have to create a class first and put the main inside class, because you cannot have a main outside of a class scope. That's why usually we create some class called something demo, for example, or application, for example, right? Or most people just, when they try to design an application, they call the entry class, the class that actually has the main method, main with capital M, right? Main, for example. And then now, as you can see in the main, we are actually defining our application, which means creates two instances of this class, which means these are our objects, and then do some stuff with them, do some actions on them, and then the application ends, right? The output of this test prints the ending pedal cadence, speed, and gear for two bicycles. All right, so this was the introduction to class, and again, to just simply put, it's a blueprint on when you create an object of that type, what kind of data it's going to hold and what kind of actions, behaviors you're going to is going to happen on those data, right? And the other thing is about the main, and the point here is that main has to be inside the scope of class, which is, in terminology, it's called the main class. In this case, it's bicycle demo or something, right? You cannot have a main outside of a class because there is no global scope in Java. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.